is equal to, just consider vehicle speed. What is the speed of the vehicle is traveling, minus consider the wheel speed. What is the, I mean, how on which speed the wheel is rotating, divided by vehicle speed. The vehicle speed is in the sense the translation velocity, and the wheel speed is in the sense rotational velocity. So translation velocity minus rotational velocity by translation velocity. That is what I'm going to mean. Here I mentioned as it is a just made it as 1 minus wheel speed by vehicle speed. When vehicle speed minus wheel speed by wheel speed, if you are dividing it, this will be the 1 minus wheel speed by vehicle speed. So this will be calculated. This will be calculated by help of inertial sensor and wheel speed sensor. Wheel speed sensor. Wheel speed sensor is in the sense to detect what is the RPM of the wheel. By means we can able to calculate the vehicle speed. Inertial sensor is the sense it will see what is the pitch, roll, and yaw moment. It will be having 3 directional sensor: x-axis, y-axis, and z-axis. So whether the vehicle is moving or all the 4 wheels are directly stationary, it is rotating, we need to check. Using wheel speed, we can able to create what is the vehicle speed, but actually the vehicle is moving or not, we need to check, because if all the 4 wheels are kept in the roller bench, and if you are rotating the wheels, all the four wheels will be keep on rotating, but the vehicle won't be moving. If the vehicle is not moving, this is happening means then the TCS will think, okay, vehicle is moving properly. The software won't able to calculate the exact thing, so we need some other external factor to predict it. So that is what inertial sensor will help in this. So it will sense using the inertial sensor input and vehicle speed sensor input, it will calculate, and it will reduce the engine torque or apply brake torque depending upon the situations. Okay, in what are the perspective in where it will be reducing the engine torque and where it will be applying the brake torque, you can see in the next slide. Traction control system will be working mainly by applying brake torque and by reducing the engine torque. This function will mainly work on the drive axle, what in which if it is a front wheel drive, in the front wheel drive only the traction control system will work. If it is a rear wheel drive, in the rear wheel drive it will work. If it is all wheel drive, in all wheels it will work. Only in the drive axle it will work, not in the dead axle. Only in the drive axle this traction control system will work. Engine torque. Okay. Like while explaining the traction controller, if we are giving the excessive power to the wheels than the required power, obviously it will spin. So to avoid this, if we are in the IC surface, all the 4 wheels are in IC surface, and we are trying to move the vehicle can't able to move because we are giving excessive power, so that the wheel will be spinning. During that time, what the traction control system will do is like it will reduce the engine torque. The ESP will request the VCU, vehicle controller unit, to reduce the engine torque, or it will reduce the engine torque for combustion or for electric also. For both combustion engine and electric vehicle, it will reduce the engine torque. If it is a combustion engine, it will be having certain limit called stall factor. If the up to certain limit, if you are not up to 700 RPM will be the stall RPM. Below that, if you are going, the combustion engine will shut down. So for electric motor, there is no that kind of situation. We can go up to 0 also. We can increase up to 3000, 4000 RPM also. So there is a much space for us to do that. But for combustion engine, there won't be that much space. The thing is, we need to up to 700 RPM only we can able to reduce the engine RPM. So up to certain limit, we will be reducing the engine RPM in the IC surface. Even then the traction is not, we are not gaining the traction. Then we will apply the brake torque to the individual wheels to come out to get the traction. Like TCS will reduce the spin by reducing the engine torque and provide the optimum torque so that the vehicle will recover and move forward. This engine torque reduction will be predominant during all the 4 wheels are in the same U. This engine torque reduction will be working mainly on the predominant only on all the 4 wheels on the same view, like IC surface or water surface. And the brake torque, what will happen is, what will do is like, if the vehicle is in different mu condition, consider left and right wheels are in different mu conditions. At the time the traction is not gaining, one wheel is alone, it is spinning. Then what will do is like it will apply the individual wheel which is spinning. It will apply the brake over there, so that because of the differential concept, it will directly transfer the power to the alternate wheel so that the vehicle will come out of the whatever the surface it is there. If it is a mud, it will come up of that and it will recover it. So it will remain. So this will have the brake torque will work mainly, predominantly will work on different mu surfaces, and engine torque will predominantly will work on it is not like in same mu surfaces only engine torque will work. In same mu surfaces, first engine torque will work, then brake torque will work. In the second condition, first brake torque will work, then only the engine torque will work. That is the predominant will be like this is the condition. The vehicle is, they are making the vehicle to stand still in the slope. It is a icy surface. Now he is trying to press the accelerator pedal. He is trying to move, but the vehicle is keep on spinning. The red one is the without TCA system. The blue one is the with TCA system. The red one, see, the red one is keep on moving backward. It is keep on spinning. The red one is keep on spinning, but the blue car is trying. It is moving ahead because this is because the blue is having the traction control system. It will reduce the engine torque, it will apply the brake torque to overcome this, and the traction will be gained. Then the vehicle will be trying to move. Prevent the drive from spinning occurring when starting or accelerating on the slippery roads, particularly on the snow road. Snow roads, if it is a snow road, it will predominantly it will having the engine torque. Then we can go to the VDC, vehicle dynamic control. What is vehicle dynamic control? The traction controller is like spinning. If the vehicle is spinning, we need to recover it. But what the vehicle dynamic control is like, all the drivers won't be the expert drivers who is driving the cars in the our regular roads. So some will have some, they are not that much experienced. So what the VDC controller will do is like, if the vehicle we are driving at certain, I mean up to, if we are driving the vehicle at too high speed, and at some situation we can't able to control the vehicle because we are not the expert drivers. So what the VDC controller system will do is like, vehicle dynamic controller system will do is like, it will assist the driver so that to avoid the accidents. It will assist in the sense, it will make the vehicle steerability and stability. Both the things they will be helping in doing that. Stability in the sense, it should not roll over, it should not rolling, the vehicle should not roll, the vehicle should not understeer or oversteer, those things the vehicle should not do. That is what the stability. Steerability is like, whatever the driver is giving the input, it should be transferred to the vehicle. It should not, if the driver is applying, giving a steering input and it should not, it is not following, means if the vehicle is not following, then it will be understeering. If it is following too excessive, then it will be oversteering. So these two things are the predominant thing in the vehicle dynamic controller, which will be experiencing. Understeering and oversteering, which I explained. Understeering, when the vehicle understeering is in the sense, here it is mentioned. The way in the first diagram, understeering, what it is mentioned is like, the vehicle is he is driving the vehicle and trying to make a turn, but still the vehicle is not following the driver's input. It is keep on following and it is going above the track, going outside the track. That is because what is the phenomenon? What is the physics behind that? Is like, a driver is going at a high speed and he is making a turn. While making the turn, the translation velocity is more and it is not transferred to the exact, I mean, what the driver is intended steering. It is having too excessive power, so that it is keep on pushing the vehicle towards a translation velocity, which is keep on going, because it is having too much inertia. What is the inertia force which is having that? We can't be able to divert the inertia. It is keep on pushing the vehicle instead of turning. Because of that, it is making understeering. What the VDC will do is like, the VDC will apply, we are moving it at a certain inertial force. We need to change the inertial force, then only we can able to make the turn. If we are moving at a slow speed, we can able to directly turn by means of steering input. So the traction velocity will be there, it will be shifted, so we can able to turn. But at high speed, the inertia will be more. Because of the inertia, we need to change the inertial force, which is pointing to a certain direction. But for changing the inertia, what we need to do is like, we need to apply the brake in the turning direction. If we are making a right turn or left turn, if we are making a right turn, then the inner wheel, the front inner wheel, they will apply the brake. Not all the individual wheels, front inner wheel, they will apply the brake, so that the inertial force we can able to slightly modify that so that the vehicle can able to make a turn. This is what happening in the understeering situation. For oversteering, okay, vehicle turns more than the driver steers. We are traveling at 80 km per hour and he is making a sharp right turn. But the thing is, the driver is making a angle of 60 degree. He is making a turn of 60 degree, but due to the shift, due to the weight shift, he is making a sudden right turn. Due to the weight shift, what will happen is like it will make the rear wheel, rear end of the, I mean, CG position of the rear end tend to shift. Because of that, the rear wheel will come. I mean, it will make a rotation of the. I mean, what to say? The vehicle will tend to rotate by making front axle as a center of point. It will make a rotate. So because of that, the oversteering will happen. In this case, it will be having lack of stability. Body slip angle and the yaw rate, it will be two lots. Okay, what is body slip angle on the yaw rate? Body slip angle, that is what I mentioned, is the inertial force which is going, the translation velocity which is moving forward, and the steering what we are giving the input, there will be angle. If the angle is too small, whatever the steering input we have given, but still it is not following and it is not turning, there will be difference. The vehicle need to turn. So on the vehicle movement and the vehicle turning moment, there will, the angle between that, it is called slip angle. If the slip angle is too small, even after steering, then it is called understeering. It will happen. It will tend to understeer. If it is too large, then it will tend to oversteer. In oversteering, it will have lack of stability. In understeer, it will have lack of steerability. The VDC help. In case of oversteering, what the VDC will do is like it should not rotate. For that, it will break the outer wheel. Okay, for oversteering, it will break the front outer wheel. It will break the front outer wheel, so that the inertial force, which is, I mean, the over, because of that, the body slip angle will be more. It should not be more, so that the in case of understeering, it will break the front inner wheel, but in oversteering, it will break the front outer wheel and the rear wheel, so that the power will be reduced. So the inertial force, which is the excessive inertial force, which is going to travel on the right side, will be cancelled by means of applying the outer wheel braking in the front axle, so that the inertial force will be recovered, so that the vehicle can make a smooth turn in the oversteering situation. See here, he is making a turn, but still the vehicle is keep on moving towards straight, because there is the body slip angle is very slow. But in case of oversteering, what is happening is like he is making a turn, but still the vehicle is the rear end of the vehicle is keep on pushing towards the center of, I mean, pushing. It is making a circle by making a front axle as a center point, so that keep on moving, and it is hitting the vehicle. It is hitting the tree. Understeering, what is exactly happening is like it can be more predictable and it can be easy to control. More predictable is in the sense the driver can experience whether the vehicle is going to be understeer or not, because we will be traveling at a certain speed. Up to a certain speed, if you are making a turn, we can experience that whether the vehicle is understeering or not. Before the understeering is happening, we can able to experience that, because this is happening due to excessive braking and hard braking. Excessive speed and hard braking. If it is excessive speed, the inertial force will be more. Because of that, the translation velocity will be directly pointed to a certain point only. We can't be able to make the change on that because of the inertial force. Then hard braking. Hard braking is in the sense we'll be braking hard, so that the braking will be split. In the front axle will be 80% and the rear axle it will be 20%. If you are making front axle as 80%, rear axle as 20% braking, the rear end of the vehicle will lift. It will lift up to certain limit, so that there will be any contact. I mean, okay, there will be any contact, and in the front there will be, I mean, the load will be more concentrated to the front axle, so that we can't be able to, if we are making a change also, it won't accept. If we are making a steering change also, the vehicle won't accept, and it will be keep on moving, and it will tend to have a understeering. Okay. For four-wheel also the same thing it is happening. They keep on moving and it is hitting the wheel. It is hitting the obstacle. Okay, how to recover it? How to recover the understeering? Understeer can be recovered by means of, if we are making a 60-degree turn, 60, if we are making the steering input as 60-degree, we need to reduce the steering input to 30-degree or some. To make a small change in inertia, we should not give the more change in the steering. We need to gradually apply the changes. So we will be reducing the steering angle, and we need to remove the throttle up to certain limit. We should not remove the overall throttle. It will tend to cross the oversteering. I will explain later. We just need to reduce the steering up to certain limit, and we need to reduce the throttle up to certain limit. If we are releasing the throttle too excessive, what will happen is like it will tend to oversteer, because all the weight transfer will be happening in the front of the vehicle, so that the rear, there will be a gap between the rear. There will what to say, because of that weight transfer, the rear end of the rear axle of the vehicle will be lifted. Because of that, there will be no traction on the rear end, so that the vehicle will be keep on spinning. It will tend to oversteer in that kind of situation. So this is what we need to do. This is what the experienced driver will do while what to say, while driving the vehicle. But this kind of thing we can't able to do it in our daily situation. I mean, the unexperienced driver can't able to do this. These things will be taken care by the vehicle dynamic controller by applying the brakes. Whatever the thing which is required, it will apply the brakes. See, because of understeering, he is lifting the throttle, so it tend to oversteer. It tend to rotate. So he is removing the throttle, and he is making a change in the steering. So now that he can able to make it turn smoothly. Lift off oversteering, that is what, if he is removing the throttle too excessive, then there will be a lift off oversteering, because the understeering will tend to oversteer. For oversteering will be happening due to the rear wheels losing the grip. If the rear wheel is losing the grip, the rear wheels will have the traction. I mean, the traction won't be there. It will be keep on spinning. Because of the spin, the oversteer will happen. The rear wheel loses the grip, and the rear will rotate. Okay. Then also there is another thing. If there is too much of throttle, he is applying too much of throttle in the turning, so that it will be keep on spinning. The rear wheel will be tend to spin because of not gaining the traction, so that it is making a oversteer. See here it is keep on. Okay. In this case, just see the rear wheel. It is keep on spinning. Because of that, the CG is shifted and oversteering is happening. Okay, body slip angle. That is what are the intended steering which we are giving. It is moving more than that, so that the body slip angle is increasing. So this is dangerous while driving for the normal drivers. The experienced driver can able to do it. Okay, the oversteering is also happen in case of too low gear. It is not like only if it is the rear wheel is spinning, that oversteering will happen. If the rear wheel is skidding, also the oversteering will happen. The rear wheel will skid when the rear wheel will skid is like, if the vehicle is moving at 80 km/h and we are directly reducing the gear to second gear, then obviously the the power which we are transferred by means of gear mechanism, there will be a fluctuation. So what will happen is like the engine braking will happen in the rear. Instead of our braking, the engine will directly brake the rear wheels. Because of that, the traction won't be there. So if in the time, if the driver is making a turn, obviously the rear wheel will be skidding, and he is making a turn, so that there will be a rolling. So that is what he is happening. He is doing here. He is making the vehicle to low gear. He is making a turn, so that he is hitting the obstacle. The rear wheel is locking. So this is what in what VDC will do is like, all the drivers can't able to do the maneuvers perfectly. So the VDC will help the drivers to do the maneuvers perfectly so that we can avoid the accidents.